So what are tangents?
The line that is the same gradient as the point on the line.
Yep, so if I was to draw a random function like so, doesn't matter what it looks like, the tangent of that function changes, does it, or does it stay the same? It changes, so if I was to pick this point here, it would have a unique tangent to every other point. Happy with that? What's that tell us? That's positive, very good. What else? What does a tangent tell us? Gradient at that point, very good. It's got a special name? Or
Instantaneous rate.
instantaneous rate of change. Okay. So if we were looking at, so that was distance, that would tell you how fast the object was travelling at that point in time. Cool? That's kind of important to know how quickly things are changing at a point in time. If your parents have ever seen a flash when they've been driving, it's kind of important to know that. Because that's what they're doing, they're seeing how much distance are you covering in a period of time. Now, normally we'd have to collect two pieces of data, divide them by each other, but this doesn't do that. Have we heard of first principles? Do you understand what first principles is going on about, or not really?
It's about, like, it's not getting 2 points, getting the secant line and then getting as close as infinity to like instantaneous.
Very good. That's very good. So basically, if we were to zoom in on that section there, we'd have 2 points on our line, and we're trying to get the difference between those 2 points, like a gradient, y2 minus y1 over x2 minus x1, and we're just trying to get those points as close to each other as possible. And then we let the distance between them get as close to 0 as possible. And you've probably seen the one where it's like limit as h approaches 0. Seen that before? Okay. Don't need to worry so much about first principles at this point in time. What I really want us to understand is what a tangent is and why it's important. So the reason what a tangent is it's a line that doesn't intersect around that point again. So it should be as close to that line as possible without intersecting it. Cool. The reason it's important is because it tells us how much something is changing at a point in time. Really, really useful for time functions. Now, how do we find the tangent mathematically? So if I was to give you this function as y equals x squared minus 1, could I mathematically find the tangent? So that point there is x equals 2.5. Could I find that tangent? Can I do what? So, derivative, that's exactly right. So I find dy dx, 2x, okay, and you see you took 1 off the power and took 1 away, took the power down, took 1 off the power. Now what do I do? So I let x equal, and I get dy dx equals 5. So what's that telling you? That says that's 5. What's that mean? The gradient of that line is 5. Because a tangent's always a straight line, isn't it? Happy with that? So you'll notice in 2a, so that answers question 1, but 2a, I've asked you to do what? What is the tangent doing? And I've asked you to do what below? So I've got your question, I've given you that graph there, something very similar to that graph, and I've said, what's the tangent doing? And I've asked you to graph that below. So, the way I would go about this is have I given you any numbers? So I'm not asking you to be super precise, am I? What am I looking for? Your negatives and positives in a general shape. So what can you tell me about this function here and its tangents? How does it start? Positive or negative on this side? Negative. So I should be over here somewhere, shouldn't I? Now, is the tangent constant or is it changing? Changing. Is it getting more negative or less negative as I come across? Less negative. And then what happens in the middle here? 0. So I want a point in the middle at 0, and then after that, it becomes positive. Does it get more positive as it goes further away or less positive? Okay, so probably going to get something that looks like this, right? Happy with that? Aligned. Remember that function we just had? What was our function? Y equals x squared minus 1. dy dx equals 2x. What does that look like? What type of function do we call that? Linear? What's that look like? Linear function. So what I want you to do is now go through, and I don't expect you to get it right. I don't really care if you get it right. What I want you to do is think about what is the tangent doing. What is the tangent doing at each one of these points? We will get to a point where I'll teach you some content, but I'm trying to get you to think before that.